This is the 4.1 to 4.2 review. Calculators are not allowed, and it's number 6. So this is a free response that is pretty involved. Okay, the first part, it's kind of going to scaffold it for you because it turns out if you can figure out the symmetry, then you only have to do half of the work when you're analyzing this function for its maxes and mins. So here I've got this function. It involves an absolute value and an exponential, and we want to determine the symmetry, and we have to justify it algebraically. So if you recall, symmetry is determined by the output of f of the opposite of x. If I plug in the opposite of x, I'll have the absolute value of the opposite of x raised to the 1/4 power minus e to the negative of the opposite of x raised to the 4th power. If I simplify this, I'm going to get absolute value of x to the 1/4 minus e to the negative x to the 4th. Notice this is exactly the same as the original function. Because f of negative x equals f of x, we can say that f is symmetric about the y, or we can say it's even, your choice. That piece is worth 1 point. You've got to have even or y symmetry and the justification where f of negative x equals f of x. So next, part B asks over what intervals of the domain is the function increasing, and then justify. Well, if a function is increasing, that means it's going to be rising. So that's just another way of saying that f increases when f prime of x is positive. So because we have an even function, we can look just at the right side and see what happens there, and then use symmetry to make conclusions about what's going on the left side. So if I write f of x on just the right side when x is positive, then the inside of the absolute value will be positive, which means the absolute value will leave it alone. So if I want the derivative of that f now, I will do the product rule, which will be the first times the derivative of the second plus the second one times the derivative of the first. Oops, that should be an x. So now our goal is to find out when it's increasing. So we will change between increasing and decreasing when this ends up being 0 or undefined. So it's easiest to determine whether things are 0 or undefined if you can write them as a single fraction. So we're going to rewrite each term as a single fraction by using our old Algebra 2 techniques. If I look here, I have an e to the negative x over 4, so that's going to go on the bottom. I also have an x to the 4th times a negative 4 times an x to the 3rd, so that will be a negative 4 times an x to the 3 1/4, which is actually going to be 12/13. And then I'm going to add my next fraction, which again has that e to the x to the 4th on the bottom. And then here I've got a 4 on the bottom, and then I have an x to the negative 3/4 on the bottom. So on top, all I've got is a 1. So before I can determine when this whole thing equals 0 or undefined, I'm going to want to get a common denominator because it's a lot easier to work with if I have a single fraction. So to get a common denominator, I can see that this fraction right here needs a 4, and it also needs an x to the 3/4. So if I multiply this top by a 4 and an x to the 3/4 on both the top and the bottom, then I can multiply the tops and then combine. So when I do that, I will get a negative 4 times an x to the 16/4, which is actually just a 4, plus a 1, and on the bottom I'll have a 4x to the 3/4 times an e to the x to the 4th. I'm interested in knowing when this is 0 and when this is undefined. Remember, fractions are 0 when the top equals 0. So that's going to happen when negative 4x to the fourth plus 1 equals 0, or when x to the fourth equals 1/4, or when x equals the fourth root. Somewhere I'm messing up. I forgot my 4 times my negative 4. So sorry. Backtrack. This is a negative 16. Should come out evenly. So that'll be when x to the fourth equals 1/16, and that will be when x is plus or minus 1/2. Now bear in mind that this branch is only effective when x is positive. So really, we're going to get x equals positive 1/2 from this analysis. But because of the even nature of the function, we'll also go back and get the negative 1/2 on the other side. So to analyze when we are increasing and when we are decreasing, we're now going to do our analysis of f prime. And on f prime, we're going to put the problems in the domain and the critical points. So on the right-hand side, we had a critical point of 1/2. Because the function is even, we're going to have that same critical point showing up at negative 1/2 on the left. So those both generated zeros. Now we also have some undefined stuff going on. So here we can see that when the bottom is 0, that will occur when x is 0. So at x equals 0, we have an undefined slope. So how do we figure out the nature of that undefined? If we look up at the beginning, we can see that 0 is not a problem here. I can plug 0 in and get a 0 out. So that means we're having a problem either with a corner or a cusp or a vertical tangent. So we'll analyze to see what we get in a little bit. I think it comes down to part E where we have to sketch it. So if we want to now analyze when f prime is going to be increasing, remember this f prime that we have written here is only for the right side. So we can only look at what's going on over here. So between 0 and 1/2, we could maybe try a fourth. So a fourth raised to the fourth power, this will end up being a fraction whose magnitude is smaller than 1. So if we add that negative fraction plus a 1, we'll end up with a positive on the top, and the bottom will also still be positive. After 1/2, say at 1, then raising 1 to the fourth will be a positive 1 times a negative 16. We're going to get a negative 16 plus a 1, which makes a negative on the top, and a positive on the bottom. So we can see that we are going to be rising and then falling. Because it's even, I kind of ran out of space here, we're going to have that same behavior. So we're going to rise and then we're going to fall, and we're going to rise and then we're going to fall, and we're continuous at 0. So it's either a corner or a cusp there. We don't know for sure, but we can at least look at picture-wise that we've got a non-differentiable point there. So looking here, we can see that we are increasing from negative infinity up to negative 1/2, and then we're going to increase again from 0 until 1/2. So the increasing intervals will be negative infinity up to 1/2 negative, and 0 to 1/2. So we'll write f increases on these two intervals. And the reason it does is because f prime is positive. So on this one we get 3 points. We get 3 points for taking the derivative for the branch of the function that is bigger than 0. So 1 point for doing that. We get another point for finding the critical points, which was 1/2 and 0. And we get a third point for finding both of the intervals. So altogether we end up with 3 points on part B.